All right, hey, my name is Michael Stonis. I'm a managing partner out at 8bot. We're a Xamarin consultancy in Chicago here. We really focus in on doing Xamarin mobile applications, and for our apps, we use a lot of ReactiveUI and reactive extensions. So obviously, that'll be our topic here for today, so something that I'm pretty passionate about.
Hi, my name's Jeff. I'm a Xamarin developer from all the way back in the beginning. I'm currently a lead consultant at a consultancy here in Australia called Reactify. Open source is pretty important to me. I joined the community back in 2013, learned a lot through that. And if you ever wanted to get involved in the community, I maintain a small little backlog that are perfect for your first pull request. Send me an email. I'd love to get you involved. Apart from that, I run a weekly newsletter called Weekly Xamarin, and it goes out every Friday. It's currently got 1,800 subscribers. It's been running for 110 weeks. It contains a hand-picked roundup of the best Xamarin developer links for that week, plus insights from before. So that's the introductions done. Over to you, Michael.
Yeah, sounds good. Yeah, and Xamarin Weekly is pretty awesome. Great place to keep up to speed with everything going on with Xamarin. Obviously, in the mobile world, stuff moves quick. So, all right. So, like I mentioned, what we want to talk about here today are reactive extensions and reactive UI. And I think kind of the best way to start off by talking about this is sort of what is the need for them, right? And from my background, I kind of came from a background doing enterprise development and sort of large software development for integration platforms. And and when we did those development, or when I did that development rather, there were a lot of things I didn't have to worry about. Network reliability, in most cases user interaction for those things, and especially like limited resources, were all things I didn't have to worry about. If the network was down, that was a huge issue. User interaction, really again, pretty simple web UIs for those things, so really not anything crazy. And then limited resources, right? If you think of a server, we're talking like 32, 64 gigs of RAM, multiple CPUs, all kinds of power to get your work done. And so when I made the switch over to mobile development, these were all issues that became, top focus issues for me. How do we make sure that we can retry if something fails? How do we make sure that users can't tap buttons while we're downloading data, or can't tap buttons multiple times and things like that? And then finally, how do we make sure that we make the best use of our resources that we have? We're talking about these mobile phones, even the latest mobile phones, they're not the most performant things, and really the amount of memory that we have available in our applications is pretty minuscule. So how do we make sure that we develop apps that not only perform well and work in these different environments, but that also can be maintained or easily maintained without too much spaghetti code, right? And that's where I first came across, in looking for a solution there rather, that's where I first came across the reactive extensions. So they're not something that's exactly new. They were actually introduced in 2009. They were developed by Microsoft, and I think they originally developed as part of their Bing components on their server side. And really what the idea here for the reactive extensions is a set of libraries or a set of extensions that we could use when we're building asynchronous and event-based applications. And this really rung with me, right? Because if we're thinking about building mobile apps, most of the stuff that we're doing, whether it's network communications, file system communications, serial communications or anything like that, we're doing all of that in an asynchronous manner. And that was something that I wanted to make sure that, that I can have my apps continue to do and continue to work that way. And then everything else from the UI side is essentially event-based, right? When a user clicks on a button, when a user tries to do a pull to refresh, all these types of events are things that we need to listen to in our applications. So I came across these reactive extensions. They seemed like something pretty neat, but there really wasn't a lot of great documentation about them online. And it also seemed kind of weird that a lot of people weren't using them. So what I did is I started to do a little bit of digging. I noticed out there that you could find the reactive extensions in NuGet just by searching for RX-. And that's actually changing, or has changed lately. The reactive extensions are now available. If you search for reactive extensions on NuGet, you'll find the newest 3.0 packages out there as well. But so they were available, as an installable item via NuGet. And as I kept on looking out there, I found out that, hey, there are some companies that use it, So it was companies like Microsoft and GitHub, Trello, Netflix, big companies that were using it. And a thing that I found that was kind of interesting about it as well is that it wasn't just being used in the .NET world. If you look for reactive extensions, you'll find implementations of it that are used in Java or Ruby or even like C++ where you could find it. In particular, in the web world, the reactive extensions and sort of reactive programming has really seemed to take off. So it was something that I thought, again, if these people are using them, if these other languages are using them, what can we do to bring them into .NET, or why aren't more people using it? And so what I want to do here today is just kind of talk over how we can introduce these into our apps, and sort of talk over the base concepts that I think really scare people off from using reactive extensions, and hopefully give everybody kind of that fundamental understanding of what using the reactive extensions are, and then how you could integrate them in your app. All right. And so one of the first things that I think that we have here to consider is when would you really want to use these inside of your application? And so one of the first places that comes to mind is real-time data. Imagine you're building an application that goes to a stock ticker or even integrates with something like Twitter. It's something that's constantly updating. It's not just like a one-time data pull or anything like that. And if we were to do this traditionally using just async and await, maybe we'd need to implement something like a timer to go listen for updates and things like that. And it doesn't really work, as nice as I feel like it could be. And that's really one of the places where reactive extensions shines, right? It gives us a way to interact with data that's constantly updating, whether it's real-time data, potentially streams of data, right? If you're doing something like integrating with a Bluetooth connection or over a network connection, and that data sort of continuously flowing in, reactive extensions give us a lot of neat components to work with it there. And then finally, I find it to be a really great tool when we're building out our user interfaces. So again, when we think of building UIs, we've got very complex interactions that can happen. Button clicks, taps, swipes, all that kind of good stuff that happens in a mobile application. And the reactive extensions give us a way to kind of listen for those events that for when they occur, filter that data down, potentially merge data together so that we can handle it in a more consistent manner and things like that. And so just to kind of get your brain going there of where you can use it, these are three pretty common places for us to introduce that into our app or applications. All right. So what are the core concepts of reactive UI, of reactive development? And it really comes down to two pieces. But before we go into those two pieces, I always like to start here with something familiar, right? If we're .NET developers, everybody here has probably worked with IEnumerable, right? It's the core interface that we use for things like list of T, right? And IEnumerable kind of works this way. You go and query for some data, or you go and retrieve some data, and IEnumerable gives it back to you as a package, right? And then it's your job to open up that package and to pull data out of it, right? So, if you go and query an API, that API will deliver this data back to you. And then we're going to enumerate through those items, and on a piece-by-piece basis, we're going to pull data out of there, right? And so a typical IEnumerable usage might look something like this, like a for each, right? Again, this is very simple, but the idea being that, hey, maybe we queried an API or a database, or we have some cache data, something like that, and we just have this list of people out here, and we're just going to enumerate for it. The key thing to keep in mind with IEnumerable, though, is that that data has been pre-packaged to you. It's basically a one-time delivery type mechanism. So data's been retrieved, packaged, given to you, and then it's just your job to unpack it. All right? So the first way that reactive extensions differ here is that we aren't going to use IEnumerable, right? What we're going to use instead here is IObservable. And the biggest difference now is that IObservable isn't going to just deliver you a package of data. IObservable is going to give us a stream of data. It's going to essentially push data to its subscribers. And so the idea here, or the biggest difference, I think, is that we can't think of it as sort of a package that has been delivered. It's more like a conveyor belt of packages, right? So now we've got a stream of data that's being delivered to us. There might be just one package. No packages may actually end up getting delivered to us, or we may just have a never-ending stream of data that's delivered, right? So if we go back to kind of thinking of those examples, right? If we're connecting to something like Twitter and we're getting data from Twitter, maybe we're getting a flood of tweets in because people are talking about some big world event that just occurred, or maybe it's nighttime and nothing's happening, right? But the idea here is that we can always just set up some way to go and retrieve that data and notify us back. What's also neat about observables then is that we could process them using link or a functionality that we're already familiar with. So the ability to do things like a link statement where you would say a where clause to filter data down, or a select clause to transform data before it goes on to its next step. A lot of those concepts still carry over here in the reactive world, and I'll show some examples of that in just a few minutes. All right, so when we're looking to create observables, they might look something like a few of these examples here. So the first example that I have is just creating an observable of a range. Essentially what this is going to do is it's going to send me out notifications between the number 1 and 100, and it's just going to put those, again, if you think of that conveyor belt style mentality, it's just going to take those numbers and it's going to push each one of those numbers onto the conveyor belt and notify me for each item in that range. The next example here is creating an observable based on a timer. So what this means is that every 3 seconds, I want to receive a notification. Right, so again, this is similar to something that we might do today using a built-in timer, inside of .NET, but now we could use it as a key to send off on our stream. All right, and finally then what we have here, and this is I think one of the coolest pieces, is the ability to create observables from event handlers. Right, so we could say observable.fromEventPattern, and then you'll see in this example here I've got a text entry, and I just want to say whenever my text is changed, notify me of it. One thing that you may notice in here as well is that it is using sort of the standard event subscription pattern inside of it. And we're going to actually set up right here in one spot our subscription to receive those notifications, and then also to remove that subscription as well. And we'll go, again, we'll kind of go into that in more depth here. But it's something that you can see, we've got a range of ways we could implement these. And these are just a few ways that we can create observables. But we've got a lot of different ways that we can start getting that data passed back to us. Like I said, though, this is essentially just one side of the reactive extensions. This is our side that's going to send data to us. So if we were to keep it right now, just like it is, right, it's essentially a package that's going down a conveyor belt, but there's nobody there to receive it. Okay, if we were to do this again, we might have another package that comes down the conveyor belt, and nobody's there to receive it. So what we need to talk about next is the second half of the reactive extensions, and that's creating our subscriptions. Right? We actually need to give some way for somebody to receive those packages in here. Right? And the idea behind the subscriptions in ReactiveUI is that we're going to have different subscribers listening to those observables, and then for each value that comes down or that comes out of that observable, we could then subscribe to it using an action, and we could filter down that data further, or we could process that data and do our unit of work. What's also neat about that is if you have that observable or that stream of data, you can actually connect multiple subscriptions to it. Right? So if you have 2 or 3 or 4 different units of work that you'd like to do for each one of those packages that come down the conveyor belt, we can actually apply that data using the subscription. Finally then, when we're all done with our subscriptions, right, so if we're done gathering all of our data, maybe the user's shutting down the application or leaving the current page that we're on, we just shut down all those subscriptions using iDisposable. So we basically just, dispose of those items, and once that's done, all of our subscriptions are nice and cleaned up for us. All right. So another way to kind of think about this is sort of in a holistic way, is to kind of think of fishing. I do a lot of fishing. I like fishing quite a bit. If you don't fish, I apologize. But this relates to me. I go out a lot of weekends out of the year and go fishing with my boys. So the idea here is that our subscriber in our example here is going to be the fisherman. The fisherman wants fish, right? But the fisherman has no way of actually obtaining those fish. It just knows, hey, when I get one, I need to do something with it. Our observable here is going to be our bobber then, right? You imagine we cast our line into the water, that bobber's sitting in the water there, it's got a hook on it, and it's just waiting to catch fish, and then it's going to notify us whenever we've caught a fish, right? It's going to go under the water and notify us, hey, you've caught a fish. So what happens then is every time we find a fish, we could be notified of it, and then we could subscribe to it if we'd like, right? Hey, that's a fish that I want. Let's take that in and let's process that further. Again, we catch another fish. That's another fish that I want. We're going to subscribe to that and we're going to use that. But what if we catch something that we're not interested in, right? We're going to catch this shrimp or this crustacean, right? Maybe that's something that we don't want. Well, using that same idea, that same kind of a notification idea, we can also filter out items, right? So we could blast it away, and we could say that's not actually a data item that I'm interested in. But then later on, if we get another fish in, we can actually subscribe to that as well. So that's kind of how these two pieces work together. Again, the observable is the piece that's actually going and retrieving our data for us and putting it on the conveyor belt, or sending us the notification. And then finally, us as the observer, we're going to take that data and consume it, or do whatever we'd like with it. Okay? So how does this actually look in code then? Right, so in code, a typical subscription might look something like this. On the second line, you'll notice that we've got this item called fish observable. Again, imagine that that's our conveyor belt. That's the piece that's essentially pushing the notifications out to us. What we want to do with those notifications then is to subscribe to them, right? So we could say here, hey, each time I get a fish notification in, I'm just going to do a debug write line, and I'm going to write out that fish's name, right? So pretty simple. Kind of looks similar to what we might do with something in LINQ, right? You might say a .select here or something like that. And then when we're all done with that observable then, or when we create that subscription rather, we're going to get this subscription object out of it. And when we're all done using that subscription, we just call dispose on it, and that will release our subscription there. So it's kind of a nice, clean way for us to clean up any of the work that we've been doing there along the way. We can also do more complex things with our observables as well, though. Right, so if you go back to that fishing example that I had shown off, like I had mentioned, we have fish that we're receiving. What if those, maybe fish isn't the best word here, but what if those sea creatures that we caught is a crustacean? Well, what we could do here is we could introduce LINQ, right? And I could say with LINQ, I'm only in fish or sea creatures that are not crustaceans. So everything else, throw them away. I don't even want to be notified of them. Furthermore, we could use LINQ to filter down our data or transform our data. So here you can see I'm using a select afterwards, and maybe I'm only interested in the fish's name. I don't want every part of the fish. I don't want everything else. I just want to know the names that came through. And then finally, we could subscribe to that fish's name, right? So we've taken that same data, that fish object, we filtered it down to a string of just the name of that fish, and then finally we could use that to write it out to our debug write line there. So again, what I like about this is as you may notice, is we start to build a story. And that's something that we'll come back to a few times here. But the idea is that we've got some kind of notification mechanism, that's our observable, and then we've got our story that we write after it, how we filter it down, how we select the data, and then finally our subscription where we're going to do our work with that data. All right, so from kind of a high-level perspective, that's our kind of a quick overview of the reactive extensions. And like I said, we're going to look at some more detailed examples here in just a moment. One of the things that I found that's really cool, though, on top of the reactive extensions here, is ReactiveUI. So ReactiveUI is this kind of interesting MVVM framework. It's essentially just a series of extension methods on top of the reactive extensions, and it gives us really nice ways to build elegant, testable user interfaces. It's not very prescriptive. It's not something like an MVVM cross or even like Xamarin Forms, where it's got kind of certain MVVM patterns that you should employ and certain ways that you should create pages and things like that. It's fairly free form in how you implement it, but it does have really good support for a lot of our different .NET platforms there. So, whether you're building an application in Xamarin Forms, Xamarin Android, Xamarin iOS, if you're building it in WPF or even Windows Forms, there's essentially extension methods and hooks for all those platforms to help you build out your applications faster there. And even if you are using a different MVVM framework, something like MVVM Cross, or if you're using the parts that come out of Xamarin Forms, we can actually introduce ReactiveUI onto those platforms as well and kind of get the best of both worlds, right? You can have that core platform like MVVM Cross that maybe you really like, but now we can get some nice additional bonus features out of ReactiveUI. Finally then, if you want to find out some more information about ReactiveUI outside of just the session that we have here today, you can jump out to reactiveui.net. That's sort of the home on the internet for all things ReactiveUI. If you're looking to find some documentation, code samples, and things like that. Jeff, I don't know if you have anything else you'd like to mention about Reactive UI this time?
Yeah, so Reactive UI is not new. It started off as a project by Paul Betts. Paul Betts is a ex-GitHub engineer who now works at Slack, working on the Slack desktop application. Reactive UI is used in the GitHub for Windows desktop and also the Slack application for Windows Phone. But the interesting thing about it is it started in 2011. Actually, it started a little bit earlier than that, I believe. But it's almost old enough to go to grade school. It's a very mature platform. We have a few questions here, Michael, if now's a good time to go for it.
Yeah, so we're going to, in just a moment, we'll switch gears. But yeah, I'd be glad to answer some questions here.
Yeah, sure. First question we've got is... First question is RX versus MVVM cross. Why would you do a reactive design versus MVVM cross?
Oh, sure. Yeah, so I mean, reactive MVVM cross is really going to be a platform more to help you describe, your UIs in a more generic, consistent way across platforms. You might use Reactive UI or the reactive extensions in addition to MVVM cross to help you do, some further interaction with your user interface and things like that. I can actually give an example of when we ended up using this just a month or two ago on a project we were working on. So, a project we were helping a company build out an app using MVVM cross to define all of our MVVM, our view models, to do all of our UI and everything like that. And then we hit a point where we actually needed to integrate with Bluetooth dongle for automobiles. And so in that case, to actually get that data, to filter it down, to make sure, if we had any missing packets that we could, sort of join the data back together and then present it back to our view models, we actually ended up using the reactive extensions with MVVM cross just to enhance that functionality. Originally, they had written that just using a full-on event-based pattern, and it became kind of problematic. But after we were able to get those reactive extensions in there, we could kind of get it in one nice, easy-to-use, composable way to introduce into our applications. Furthermore, I guess if you want to use Reactive UI does have its own binding framework as well. So if you want to use separate bindings from MVVM cross or something like that, you could introduce those elements there as well on top of that platform.
Thank you, Michael. Next up, we've got a question is, what is the difference between PubSub and iQueryable, and how does that relate to RX?
PubSub, is this essentially the PubSub pattern which implements? I don't know a great way to answer that question, to be honest with you. I guess it sort of is that pattern where you've got a publisher and a set of subscriptions on top of it. So I guess in a way it is that pattern. I don't know if there is any big differences between the two, to be honest with you, though. So I guess I can't give a 100% answer on that one. But it's a pretty similar style of idea there.
Next up, we've got a question regarding the similarities between RX and some of the concepts with Redux.
I don't actually know anything about Redux. Jeff, I don't know if you know anything about that.
Not at this stage.
Yeah, sorry. I assume Redux is in I believe that's a web framework. Is that correct? I might be totally wrong about that. I actually don't know too much about it, so sorry. I don't have any really great answers there for you.
All right, stay back afterwards, and we can discuss the similarities and share some knowledge with that. Michael, how do you find debugging reactive applications? Because you're no longer doing breakpoints on state and sense. You now have event streams and understanding what caused an event to fire.
Yeah, so you do have to take a slightly different approach to debugging, and that's something that I'll show an example of as we're kind of working our way through. So again, we'll take a look at some code examples here, and I'll show you some ways that you can do some more, instrumentation inside of our applications to get us some good debugging information out and things like that. But you are going to need to kind of do a mind shift here on a little bit of your debugging, right? It's not going to be something where you've got maybe just an event handler out there that's notifying you of your data. We will need to, potentially provide some additional instrumentation, or maybe even write our reactive components in a way where we can introduce things like breakpoints. There's nothing that actually stops you from using breakpoints in ReactiveUI or anything like that. It's just kind of knowing where to use them and to understand, what data is actually being provided to you. Like I said, we'll show some examples here in a little bit, and hopefully that'll give you some ideas of how to do things like debugging and get some more instrumentation data out of your apps in a nicer way.
One final thing, we maintain a Slack community, so if you would like an invitation to the Slack community, send me a message and I'll send an invitation over to you. We find the best way to start to learn these concepts is together around a communal fireplace where we just share the knowledge on the journey of learning these concepts. I think it's time to move on to code.
Sure, yeah, no problem. Hang on, really quick, there is one other question I saw here asking, does this relate to SignalR in any way? Not exactly. Yeah, SignalR is just a web framework to allow us to get notifications and things like that. It's in no way directly tied here to reactive UI or reactive extensions, right? That's just a way to send notifications, to do some sort of web notifications and real-time communications using web protocols. You can do some things with reactive UI to make it nicer and to actually build out that implementation there, but they're not in any way directly tied to each other. All right, let's jump forward here then really quick. Let me get back to here. Right, and so what I want to do is kind of show off some really quick examples, and then we kind of are going to show a little bit of an evolution of code, right? How do we go from taking something that's purely, I'll say, like the traditional way of writing .NET code? It's not going to be perfect. It's not going to have MVVM and all that kind of stuff like that in there at first, but kind of a derived example to show us how we can take maybe an existing application or a legacy application, and how can we introduce reactive extensions, and then finally how can we introduce reactive UI on top of it, and sort of what are the benefits there along the way. All right, so I'm going to switch back to code here really quick and go back to my desktop. If anybody needs me to make this my font bigger, let me know. I try to biggie size it as much as I could, but if we need to get that any bigger, just let me know. And like I said, what we're going to do is kind of work through some code examples here of how we can introduce reactive extensions into our apps. Before we go too far into it, I actually have a whole sample application showing you different ways you could use different reactive extensions in your apps. We're not going to have time to go through all of it here today, but I will send a link out later on at the end of today's session to show you where you can go get it off of GitHub. You could pull it down. It all runs off of Xamarin Forms, so it's just a Xamarin Forms application. It should work. I've tested it at least on iOS and Android. But if you want to go ahead and run it, it shows off some features of things like delayed text entry. So, hi, my name is Mike. Things like this, where we can have text entry come in and we could delay it for a period of time and then notify out, do something like that. Just kind of show off some of the fun examples. We could do a combined latest. So if we had, say for example here, you wanted to do things like build a color picker. I've got examples in there to show how can we get the latest red, green, and blue color samples and bring them into our apps and things like that. If we have time at the end of the session when we're answering questions and stuff like that, I'd be glad to go through this in more depth. But like I said, what we're going to look at here today is kind of an example of how do we go or make the evolution from sort of a standard search to a fully reactive UI search implementation. All right, and what we're going to do here for our example is we're going to have a text entry up on top and then a search button. But the two of these things we're going to have work together, right? So, most of us have grown up here and we're used to having type ahead with things like Google. And so in this case, what we're going to do is we're going to implement type ahead here to search out to our web server. And then we also want to be able to research again later if we click that search button. So if we search for something fun, I think I had a couple examples. Battletoads, right? I can search for Battletoads here, give it a little bit of time, and then you'll see it's going to go and actually execute my query. and load my data into the UI here. I can click search again afterwards, right? So if I hit search again, it's just going to requery out to there and go get that data and show it here in my list view again. All right, but nothing too crazy. But let's actually go and see the implementation of what it took to do this in sort of that traditional .NET way. All right, so if I jump back to code here really quick, just go out here to our standard search file. Hide that out of the way here. There we go. All right. And so again, this is all just being done using Xamarin Forms. The code, all the UI is in code here. I know everybody loves XAML. Don't yell at me too much. Just makes for a better presentation, makes things a little bit easier to read, all right? But the idea here is that we've got sort of a simple application, right? If you look at it from a UI perspective, it's a pretty simple UI. It just has this text entry here. We have the ability to, we have a search button down there, and then we have a list view that's going to show out our search results. But what you may notice all the way up at the top here, the first thing that really stands out is that we're going to have to maintain a series of state variables for our search here. We've got things like our time span. You know, how long do we need to delay our search? We might have a date time offset saying when was the last time our search was actually executed. Additionally, we might have to have our, we might want to hold on to our last search term to know, you know, has that term changed since the last time we typed it in there and things like that. And then finally, I've got this delay execute. This is essentially just a timer. This is written in a PCL library, so we don't have a great way to get access to a timer here. So I just use this delay execute to allow us to do that. All right. But if we kind of start combing through our code here, you'll see that the first place that I think, or that I hate dealing with traditional code, maybe hate's a strong word, but the first place that I always fear dealing with traditional code here is when we get to the part where we set up all of our event subscriptions, right? So, you know, this is Xamarin Forms, we just have our page coming in, and we want to set up our event subscriptions here in the on appearing. Okay, so what we're saying here is that, hey, we want to listen for text changed and for our click events. And the reason why I don't like seeing these is because as soon as I see this, I know that I'm going to have to play like your choose your own adventure code game, right? So I want to know what happens when my text entry changes, which means I need to go to this method down here, which means I need to scroll down to the text changed, right? So I got to say, okay, well, what happened there? My text changed. Okay, well, we set up this timer component here, and then when that timer component fires off, it's going to go into do search, right? And that'll do the search method. Okay, we'll come back to that in a second. So we've got that figured out. But then I might also have this other search clicked up here as well, right? So if I'm doing search clicked up here and I click that event, you know, where do we go and find out about that? Oh, okay, well, that's down here, and that's going to do the same thing. It's going to end up calling do search for us as well. But again, I've got to scroll all the way down. I've kind of got to jump back and forth through all my code and find out where I'm actually executing all those components. So again, you know, it's the traditional pattern. You know, we've got other things that we could use nowadays, like commanding and things like that. But I still see a lot of this in our code for clients that we work with. The other thing that I don't like about it that kind of plays right in with that pattern is we have no direct way to ensure that these event handlers ever got cleaned up, right? So if we subscribe to text changed and clicked, we have no way to guarantee that those are getting disposed or cleaned up later on. So, you know, I've done my due diligence here on lines 66 and 67, but it could have very easily have been missed, right? Say we had a third event handler that we signed up or that we subscribed to that we didn't actually unsubscribe to later on. I have no real guarantee or one clean way to shut down all those subscriptions. So again, a very common issue that you'll see in .NET kind of all over the place, where people miss unsubscribing from events and things like that, and we just don't have all of our everything cleaned up in a nice, clean manner, right? Finally, then, if we go down here in our traditional search manner or traditional search implementation, you can see we've got our do search method. Okay, our do search method, again, there's no view model on this, so it's a kind of a simple example. Again, I know, but we have to do a lot of state management and inspection inside of here. So you can see that we're doing things like, you know, is our text null or empty? We also have to do things like check to see if we're on the UI thread or not, right? So we have to ensure, let's invoke this on the main thread. Make sure that this runs on the main thread only because we're updating UI components. Again, we've got kind of our state management sprinkled in or interspersed inside of this method here. So, when was the last search executed? Is it greater than our last search delay that had been run? If the search text equals the same search text that we had sent in before, don't actually run this, or potentially don't run this query. Things like that, right? So we've got kind of a lot of things interspersed with each other here inside of our code, and I really don't feel like it lends to something that's easy to maintain, right? Because not only that, again, just kind of to further illustrate it here, we've got state management for our buttons, such as is our button enabled or disabled at this step? When we're doing our search, we want to make it so that nobody can click the button. If we don't get any search text offsetting, that stuff, right? But a lot of little places where I feel like we can fail, or we can have code that gets missed out there, that doesn't get implemented in a really clean way. This is a very small example, but imagine we came back to this again, 6 months from now or a year from now. You're going to end up having to play again that same choose your own adventure, figure out what's happening out here, and it's not a super clean way to do this. All right, so what we're going to look at next is essentially that same example. It's a standard search again, and all we're going to do this time is we're going to introduce the reactive extensions. So again, if I search for Battletoads, 90s kids will love this, right? You've got Battletoads here. We could search and we could find our items out there again. Same kind of thing. I could click search and I can get all that data refreshed out there. If we were to come back here and search for something, we'll do search for Xamarin, right? We can get our list of Xamarin items out there after a delay from when we've been typing. All right, so let's go and see how we've taken that same example and just using that same code, that sort of same basic implementation, how do we introduce the reactive extensions on top of it? All right, so here's my code for the reactive extensions implementation here. So you can see it kind of starts out the same. We've got our views that we're going to set up and use in our application. We've got our constructor here again, where we're just sort of doing our rough UI setup. But the first thing that you'll notice is the introduction here of this new object called composite disposable. Composite disposable is this really cool thing that comes with the reactive extensions. It's essentially just a list of items to be disposed, right? So what we do with composite disposable is anytime we come across something that implements iDisposable, we could take it and we could add it in to that composite disposable. So in this case, what we're going to do is we're going to create a composite disposable that holds on to all of our event subscriptions. So that later on in our application, we can actually use that and just dispose of all those event subscriptions in one swoop. It's also really helpful for things like if you're developing, UIs and doing things like hanging on to native resources, right? So if you're in iOS and you've got a UI view or a UI button or something like that, if you're on Android and you have an edit text, and you want to clean up all those native resources, composite disposable is actually really helpful just to add all those resources into there and then just dispose of them all at one time, right? So you don't have to do any like recursive disposal or wonder, hey, did I forget to dispose of that item? Just put them in composite disposable and shut it all down later on. Okay, to implement those reactive extensions in our UI then, what we're going to do is change the way that on appearing happens, right? So we're going to move away from just that traditional event-based subscription, and we're going to start adding in our reactive extensions. Okay, so this is where I think things start to get cool, and where we start telling stories in our code as opposed to sort of having to jump everywhere around, right? So the first thing that we're going to do here is we're going to create this observable using the event pattern. Right, so we're going to say, whenever my text changes on my text entry, I want to be notified of that event occurring. So that's what this call says here. So whenever I hit, or change the text on my text entry, send me a notification for when that occurs. By default, when we send out that notification, we're going to receive the event arguments from that notification. Right, so we're going to receive out the sender in the event arguments from that notification. But what's cool about this is, when you think of events, most time really all we care about are just the event args. And even furthermore, inside the event args, there's probably a property or two that we're really interested in. So what we could do here is we could start to introduce link or link concepts, right? So I'm saying whenever I get one of these notifications now, let me select out just the new text value that I'm interested in. right? So just like we would do in any other code. For link, we could say, here's my X is my notification that came out. You can see we've got our sender and our event args, and then we could grab additional data out of here. So in this example, I'm really just interested in the new text value, right? Additionally, then, we could use this other observable or reactive component called throttling. So throttling is really neat. So what this is going to do is it's going to say, hey, after we've received data, or after we've received the last notification, hold off, 3/4 of a second, and then just give us the very last notification that came through. And this is really helpful for things like type ahead, where you might have somebody that's continuously typing, if they're searching up a really long word or a series of words, things like that. We wouldn't want to go back and forth to our API every single time that they're hitting those buttons, right? Or every time that they send in a new command. And throttle really just helps us solve that problem in a one-liner. We could say, hey, throttle out those messages, and then, after 3/4 of a second, once we've received the last message, then send me out a notification. Right, and that's going to be our first observable here. Let me get my mouse back. There we go. Our second observable then is going to be pretty similar. We're just going to say, hey, whenever somebody clicks on that search button inside of my UI, send me a notification. All right, so whenever they click on the UI, send me a notification. What's neat about this then too is you can see that I'm using that same select statement here to go get data, but in this case I'm not actually taking the parameter that was passed in is part of this lambda, right? In this case, I'm just going to say, actually, what I want you to do is go get the latest text from the text entry, right? I don't care about the event args that came from this button click that happened. I'm really more interested in the text, the value that's currently assigned to the text entry. So it's kind of neat. You can see here that I still have that same, little story of when the button gets clicked, and now I could read it in one place that, hey, go get this text entry data and just show me the text there. Finally, then, what we could do is we could take those two different streams and we can merge them together. Because realistically, whenever I'm done typing or I click the button, I really want to do the same unit of work, right? So whether it was somebody finishing typing, or if they come back a minute later and click the button, I really want to do the same thing afterwards. So with the reactive extensions, what we can do is we can merge those two streams together. So whichever notification comes off that conveyor belt, just let me know it, and I'd like to do my work. All right? And then to do that work, right, to set up that work to go do, we're going to create a subscription. And so our subscription here is going to provide us the data that comes out of those observables. In this case, we're both selecting out strings of data, right? So we're saying, grab our text from our text entry up here. And for our text typing, we say, get me that new text value. So what that means is that when I set up a subscription down here on line 80, the value that's coming in is actually a string value, right? That's going to be our search text that we could use. And then here I could just tell it, hey, go execute my search, right? So go do my unit of work for search. And then we'll take a look at that in a second. Like I mentioned earlier then, is that whenever we create these subscriptions, we could shut them down later on using a dispose pattern, right? And so what I'm doing here is I'm going to use that composite disposable object that we created earlier on, and I'm just going to add this item into that list, right? So I'm just going to take this subscription and add that into event subscriptions that need to be cleaned up later on. And what's neat about that then is that when my later on occurs, right? So when we hit that on disappearing method, all we have to do is just say with that composite disposable is to either just call clear, and by calling clear, we're going to dispose of all those items inside of it, or we can actually call dispose on it itself, which will do the same thing. It'll dispose all of the items that are being held by it, and then calling dispose on it will actually dispose itself, right? So if we're doing something where we have a life cycle that could occur multiple times, like in our on appearing and on disappearing for Xamarin Forms, clear just gives us a way to clear out any of those disposables along our way and get everything freed up from there, right? And it doesn't, so the last thing here is it doesn't make a huge impact on our do search method, but you can see that we were able to clear out some of the state management items inside of here, right? We were able to remove those things to say like, hey, should I actually search at this point in time or not search for that point at this point in time or not? It allows us more just to focus in on the unit of work that needs to occur, right? The state management has been moved up to our observables a little bit earlier on there, and now everything here is just kind of the story of that unit of work that needs to be performed. So again, this is better. I think we're making steps in the right way, but I still think we could do something a little better still, right? So our last example that we're going to look at here is doing that reactive, doing our search here using full reactive UI. So one thing you'll notice already, and you know, I built out this example to be a little bit better than the other ones because it has full reactive UI on top of it. But one of the things that you might notice here right offhand is that our search button is disabled, right? Because we've added some functionality into there that says basically disable the search button whenever we do not have any text. And we can also do things, you know, just like we did before. So Battletoads, go and find my Battletoads. And uh-oh, we had a network failure, right? Let's retry that search. Let's let that execute out there. We had another network failure. Let's retry that search again. See if we can get through here without a network failure. We got lots of them. Give it one more shot here. No, one more shot. Come on. There we go. Got through without a network failure. Right. The idea here is that we've got some ability to handle when things fail, and that's actually, you know, intended here. I've got that network failure in there because that's something that we should expect to happen in our mobile applications. Right. How do we actually account for those and react to those? And so again, let's take a look at the implementation here this time in using ReactiveUI and using a full reactive UI implementation for this example. All right. So again, things are going to start off looking the same or similar here, right? We've got our controls that we've set up right at the top here of this implementation. Again, we've got that composite disposable that we added in there previously. And then we've got our UI set up here inside of our constructor. So nothing new, or nothing too new here, with the exception that we're going to introduce a view model, right? So a view model, I'm not going to spend a ton of time going through it, but our view model is really going to be our heavy lifter here for ReactiveUI, or kind of with all of our MVVM patterns, right? And what we want to do is we want to make this user interface implementation kind of as dumb as possible, right? We really don't want this thing to know about state. We really don't want this to know about what's happening on the back end. All we want this thing to do is just serve as a point for interaction, whether we're typing, clicking buttons, things like that. We want to do all that work here. So the first thing that we need to do, like I mentioned, is just to set up that view model so we could add all that heavy lifting in on the back end. If we continue to look through here on our user interface implementation, you'll see that our onAppearing then has changed quite a bit, right? So our onAppearing now is using these bind methods. And what these bind methods allow us to do are to bind our user interface to our view model. Okay, so what these essentially say is bind using my view model, look at the property that I have in there called search query, and whenever that text changes, update the text property on my text entry. This bind is actually a two-way bind, so likewise, if I update the text in my text entry, I want to have that go back and update my search query as well. If you want, we could use a one-way bind, right? So we could take our view model, we'll take the search results in this case, that's going to be in a observable collection of search results, and we're going to assign that to our list views item source. We can also do things like bind commands. So if we have, in this example, we have Xamarin Forms. The buttons in Xamarin Forms implement iCommand. So we could say here is in our view model, we want to tie our search command to the search buttons command property, right? So we could tie those two things together. What you also may notice on here is that whenever I create these bindings, they are going to return items that are iDisposable. Right? So if I want to clean up these bindings later on to ensure that, you know, maybe once I leave this page that binding doesn't happen in the background or anything like that, all I need to do here is just take that same composite disposable, and I'll just add in my iDisposable items to it. I've got a little helper method here to help build these things out in a little bit more fluid way. But essentially, this is that same example that we saw before. We're just taking that iDisposable, and we're adding it into that composite disposable list of items. Right, so really nice and clean. Right, this is essentially our whole user interface setup here in just a few lines of code. Additionally, then we've got this item here for our user error. Right, and user error is kind of a neat thing that comes with ReactiveUI. This is essentially any time you have an event that happens in your backend that you need user interaction from. Right, so you don't need to think of it as just a user error, but imagine in this case, like we saw, we had those network exceptions, and you want to prompt your user to retry. Well, maybe your user doesn't want to retry. Maybe they're just trying to get the latest Twitter, but they realize that they're really offline and they can't get them. You could prompt them and you'd say, would you like to retry or not? And this is sort of a neat feature that comes with ReactiveUI that allows our users to make decisions, and then allows us to notify back in our view model what decisions that they've made. Right, and I'll show how that works here in just a moment. Finally then, in our user interface code, the only thing that we have here to shut everything down is just to make that same call to composite disposable and clear out our bindings. Right, so once we have everything set up here on the UI, just shut it all down. It's essentially all that's saying. Right, so like I mentioned, all the heavy lifting then is coming out here from our view model implementation. So our view model is really where we tell the story. It's where we build everything out. In the ReactiveUI world, our view models are generally going to inherit here from reactive object. A reactive object is really just a pretty simple POCO-style object, but it does do things like implement iNotify property changed, and a few other little nice things. But it essentially just gives us a nice way to use a starting point so that whenever our properties changed, we get notified in a consistent manner. All right? And you'll see that here as I set up the properties for my UI. Right? You can see I've got my search query here. Whenever I want to assign our properties using the reactive object, we just use this call here to raise instead of changed. And that will just fire off iNotify property changed and all that kind of good stuff for us whenever that change is there. Right? But pretty simple setup here in terms of our properties. Right? Just pretty simple POCO style setup with iNotify property changed. Where it really starts becoming more interesting here is inside of our constructor. And what I like about this is that this is the place where we could tell the story of our user interface. Okay? So let's just take a look here at our search command. So this is the command that's going to be executed whenever I click the search button. Okay? And our search command is going to take two properties for us, or two parameters, excuse me, for us. The first parameter is going to be to notify whether or not this command can execute. And then the second parameter it's going to take in is the unit of work that we'd want to accomplish. So let's start just by taking a look at the can execute portion of this. You know, this is kind of advanced, and I know we really haven't gone through a lot of this portion of stuff here today in too much detail. But what essentially this is saying is, give me the latest value from my search query. Right? So whenever I have a search query and I have its value changed, check to see that that value is not null or empty, and then don't notify me unless it has changed. Right? So if somebody keeps on sending in an empty string, or if somebody keeps on sending in the letter A, you know, the same, just one letter A, you know, something like that, we could tell this not to notify us. What we can also do is we could tell it, hey, I'm interested to know whether or not this command is executing. So is my unit of work shown down below here currently running? And then what I could do with those two things is I can combine them together using this reactive extension called combined latest. And so what this is going to say is that whenever I get a new value from either one of those streams, take the most recent value and compare them. And that's what we're going to do here on line 61. So I'm going to say, you know, have I searched? Do I have a search query, and am I not executing? Right. So if I'm not executing and there is text in there, then I can execute my command, and that'll lead us to do cool things like this. So if we see our search button out here, when I am searching, you can see I can't click that search button again. It gets disabled because as it's running, that command no longer can execute. So Xamarin Forms is really cool about this because it will listen to that can execute work here and disable our button for us just by using this setup here. We can also do things like introduce some instrumentation using the do command. right? So if I want to find out, when can my search be performed or not be performed, one way we could do that is by making a call to do here. And do is really kind of like an inspection. It just says, hey, whenever something comes down the conveyor belt, just take a look at it. Don't modify anything. Don't change anything downstream, but just allow me to take a look at it and log something out or do some unit of work with it. Right, so here we could just use it to write out some diagnostics information. And if I were to look out here to our application output, right, you can see that our can perform search is getting logged out there for us. So that's kind of cool. So the second half of our story then, or for our command, right, is to actually do the unit of work to query for our data. And so again, you can see I'm saying here, whenever this command executes, here's the unit of work that we'd like to perform. It's kind of our, it has a little bit of a piece here to make it seem like our web service broke, but we actually do query out to a web API and go get some data and return it out then. Right? So it's kind of that story. What happens when I click the button? It tells us that whole story. What you'll notice here then out of this command is that it actually returns a value. Right? So this command returns a list of search results. And so what we could do with this is something kind of neat, right? We could subscribe to whenever that search has completed. Not only can we subscribe to it, we could tell it to take that the values that were subscribed, and we could tell it very specifically which thread to process those values on. So in this case, I could tell this to observe on our main thread scheduler. And basically what that says is I want this to run on our UI thread, so that as those values change, continue to have that, so as I receive a notification here, process this on the UI thread. And what that means is that any subscription or any code that we put inside of our subscription here is now guaranteed to run on our UI thread. Right? So if we're doing things like impacting the state of a button, or if we're doing things like, in this case, clearing out items in an observable collection and adding new items into that collection, we can ensure that that all runs on the UI thread. And this is kind of neat, too, because this gives us the ability to do things like test this out in a unit test, right? We could say, like, hey, is this code really running on the UI thread? And if it's not, that potentially is going to break one of our unit tests, things like that. Something that could become kind of difficult to do in other MVVM frameworks out there. So kind of a nice way to do that. Finally then, I will just take a look here at the ability to listen to things like thrown exceptions. So if our command fails, right, so if that command throws an exception for some reason, like you could see up here, if the second mod 3 equals 0, right, we're going to throw a timeout exception. We have a really nice way in ReactiveUI to subscribe to those thrown exceptions. So again, we can sort of tell the story here. When my search fails, subscribe to it and do this unit of work. And that's what I really like about ReactiveUI. I could come back to this, a little bit later on, 6 months from now, a year from now, something like that. And I feel like, I'm not playing that choose your own adventure game anymore. I'm kind of just reading through this as a story and getting my information brought back to me. Right, so kind of cool things. I know we're close to our hour here, so I want to give some time for Q&A and things like that. But like I said, just sort of wanted to show that evolution of how we go to from sort of raw code to a more reactive UI implementation here. Before we switch gears, Geoffrey, I don't know if you had any questions or comments you'd like to throw in there.
Yeah, sure. Go back up to the view model and the observe on.
Sure.
Yes, there's something interesting about this. We're defining in a single place whereabouts which thread this logic will run on. Instead of, if we go back 2 or 3 pages back right at the beginning when we started, we actually, you might notice we've got begin invoke on main thread. And this is littered all throughout the code base. So, which means you actually have to go, you have to dig into the code, like nested to figure out where things are actually running. But in this world with ReactiveUI, you're actually defining in a single place which thread this logic will run on. And as Michael mentioned, it's incredibly testable.
Yeah, absolutely.
The next thing is, if you go up to user error, please.
Oh, sorry. Back in the UI side?
Yes. So the user error. Yep. Yeah, so line 60, user error, is interesting. We've actually renamed this to be user interactions in V7. And the reason we did this is because user error didn't really encapsulate what this is all about. It's more of an interaction. And compared to other frameworks, or even without a framework implementation of this type of logic, typically you'd pop a modal dialog. But when you're popping a modal dialog, you can't really unit test that. You've got to run like something like Xamarin UI test to actually test that this dialog was popped up. So user interactions or user error provides a way of modeling user interactions, and it's completely unit testable. We can actually define a behavior of, you might see in GitHub desktop for Windows, when you do a commit, it gives you an option to undo that commit for 30 seconds, and then that dialog will completely disappear. That's modeled using user error or user interactions. You can pass in observable, which will define the logic of when that interaction will be enabled or disabled, and that observable could be time-based.
Awesome.
The next thing is go to the behaviors on the view model.
Yeah, sure.
Right down the bottom of the constructor. So on line 115, you'll notice that we're using you've got a throttle, and that's only doing 0.75 seconds, almost 1 second. So we're saying anytime the search query updates, wait one second before executing the logic that occurs. So what that means is if the user is typing in a bunch of words really fast, we're only ever going to execute line 118 once there has been at least almost 1 second of inactivity, and that's defined at 115. Now what's really cool about this is really unit testable. On line 117, we actually specify the scheduler, and that scheduler has a bit of an ambient context. You can actually, in a unit test, it actually switches out the scheduler to a virtual scheduler when it detects it's running in a unit test framework. And what that means is, let's imagine that 115, instead of saying deduplicate last input was 1 second, let's say that's 5 minutes. You really don't want your unit tests running for 5 minutes. That doesn't work. But because the context gets changed to that scheduler to a virtual scheduler, you can actually switch in when that scheduler switches in, you can pass in the notion of a fake scheduler of virtual time, and that time can be advanced by a period of milliseconds. So you can actually write a unit test that specifically says after 0.75 seconds, I should be able to automatically do a search. And you can also write the same inverse unit test story saying search should not be enabled or should not fire any more than one time if the user input is multiple times within a second. So it's very, 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 very testable.
Absolutely. Really good points.
The next thing I want to point out, could you take us to the reactive object, please? Just the POCO reactive object. So here at reactive object, we've got very much just a POCO for the view model. There's nothing too special about reactive object, but it has a whole bunch of really interesting overloads or extension methods. One is suppress child notifications. If you could imagine that you have a view model that contains 50 child properties, and in your subscribe phase, from results coming back from a network, you want to update those properties, but you don't want it to, each time you update each one of those properties, which might be bound to a text label, you don't want that to cause 50 screen redraw operations. You want to actually suppress those notifications, the change notifications. Typically with other frameworks, you would have to, you can't really suppress the notifications, or you would have to suppress the notification on each child as you're updating that child. So reactive object has this amazing thing Michael's highlighted called suppress change notifications. That will suppress the change notifications for all childs on the reactive object. So if you've got a bunch of data coming in on a parent view model, you can suppress the iNotify change, and once it's executing in that scope, it won't actually fire iNotify property change until that scope ends, which is incredibly powerful because you can then, from a performance point of view, you can actually control when the actual UI of the application will do a redraw or a reflow.
Something like this. Just wrap in a using statement, suppress all them down to just one notification.
Yeah, sure. Could you go back over to the app quickly?
Sure, yeah.
So we have a standard text box here, and that has a search button. What's interesting is in this user interface, if you go, could you please go to the when any, defining when the search button is enabled, please?
Sure.
All right, and if you could pull up the UI again, please.
Yeah, no problem. Sure.
Just pull it over to the side. So something's interesting. When you start designing applications using reactive extensions or even reactive UI, you start actually implementing or declaring the behaviors or the conditions when certain activities and events can occur. It's almost like defining Microsoft Excel functions. So instead of telling computer how to add 1 plus 1, what we're doing is we're defining sum A plus B. So when we define it in a declarative way, so this is line 65, that's the when any value, it becomes very, very easy to understand under what conditions this interaction or this behavior will be true or false. It's all constrained in a single place. It's not shared at the top of the class in some mutable bag of sadness, which is updated in 5 or 6 different places in the view model. No, it's all in a single place. And because of that, it makes it, in my view, very easy to troubleshoot and debug. So what's interesting, also interesting is, it provides, when you get used to understanding and reading RX, it becomes very easy to understand the exact reasons or when a condition is true or false, or when a search button should be enabled or disabled. So that's a quick overview. That's a quick overview of some of my personal highlights, what I love about Reactive Extension, Reactive UI. I believe we've got a few questions here, Michael. Over to you.
Yeah, absolutely. Yeah, and before we get to those really quick here, I know we had a few questions about this as well. So where can I find more resources, right? There are resources available. You just got to go get out there, do some digging, I guess. So one of the great places, if you're interested again in Reactive UI, go out to reactiveui.net, and you can get a lot of really good information out there about how Reactive UI works. There's a whole team of people working on documentation to try to make that better as well. If you're interested in just the reactive extensions themselves, jump out to reactiveex.io, and that's really sort of the global hub for everything reactive extensions. So whether you're talking about using it in .NET, C++, whatnot, Java, JavaScript, reactivex.io is sort of the one grand place to go. The place that I went to that was the most helpful when I was learning here is intro-to-rx.com. This is an awesome site with tons of really good examples showing you exactly what's going on in reactive, sort of what's happening underneath the sheets. What are all those cool different commands? Things like throttling and skipping, and if we're trying to do stuff like that. What are those additional neat reactive commands that we could introduce into our UIs there? And then finally, like I mentioned before, this is the link at the bottom for the example application that I showed here today. So it's github.com/the8bot/reactive-examples. And I'll put that out in the chat as well for anybody who wants it, or for anybody who wants to grab that. But yeah, so I know we're a little bit over time, so for everybody who's hung on here, thank you so much for joining us here today. I really do appreciate everybody who's come out here and hung out hung out with us and learned a little bit more about reactive extensions. I hope you guys found it useful. I do have more time. I could hang out for a little bit until Rob kicks us off of here, I guess. But if there's any other questions or comments or anything like that, I'd be glad to go through and answer any additional questions, comments at this point in time.
Yeah, it looks like there's
likewise as well.
Looks like there's some questions there in the questions panel in GoToWebinar. So if you want to address those, I don't know if you've answered some of them, but they're still there.
Yeah, I'll take first cup off the rank. Do you have an example how to play an animation, like a loading screen, when the app is busy? So I've got this one. So it's the most common. One of the most common scenarios is you want to define a loading indicator when you're loading data from the network. So what that is you would have a property in your view model, and that would take a bool. So that's like is busy or is loading. We call them observable as property helpers or OPers, and you data bind to that to true false. At the UI layer, you have a value converter that will convert that true false for that value into the appropriate platform. So if it's UWP, you do a visibility converter, etc. So the next thing is you want to actually define the behavior of when that is loading. So what that would look like is typically we've got say if you're retrieving data from a network, you would have a network service. In this case, we've got DuckDuckGo API that returns data from the internet. And we've got a search command called doSearch, and that doSearch command executes that search service, and we have a subscription to that search service that returns back value. And what's interesting about ReactiveUI is reactive command has some guarantees. Those guarantees include that command can only execute once. So if the user clicks on the search button 5 or 6 times while the network is running a long-running activity, we actually guarantee that it only actually activates once. So you don't ever have to worry about, is this already running? We handle that for you. It's impossible. When the command is running, it's only going to run once, no matter how many times the user taps on the button until the previous invocation completes. So we've got an activity loader, we've got a view model for is loading, is busy. So we've got the view kind of hooked up and the data binding hooked up. The next step here is we have to define when that will become true. So that becomes a defining behavior. So Michael is knocking up here while we've been talking, is on line 61, he's defining the behavior. So anytime the search rx command is executing, that has a property called isExecuting, and that's automatically updated, and it updates itself, and that's actually something you can subscribe to. So what we're doing on line 61, we're subscribing to when that command is searching, it should set the loading indicator to true, and that's the end of the view model concern, and then we go over, it becomes a concern of data binding. So that's how you do a simple is loading true false activity, loading activity.
Let's see, we could find out if I could live code too. Good. Again, yeah, we could just listen. Geoffrey gave a really great example there. You know, we basically just do all the work inside of our view model, and then we could just listen to those commands. We could listen to our different observables that come out of there. And hopefully here, of our search, you can see it's searching right now. I'd given it some default data there, so we'll do Battletoads. As it searches, then you can see it animates out loading indicator. And I will, I'll commit that in there as well, so you could have that as part of that code as an example.
So the next question we've got is reactive object, we talked about reactive object has suppress notifications. So reactive object, you can actually suppress the notifications on the parent object. It handles all the child's automatically, which is excellent. But if you've got a more complex type, say a list or an observable collection, we also have you sorted there. So we have a inbuilt, we ship an inbuilt class called reactive list. And it's a collection. And this collection actually defines a whole bunch of extension methods that you can subscribe to for when you're adding data, when you're removing data, what data was added or removed. But it also has the same overload to suppress change notifications. So as you can see here, we're putting in here. So we're actually going to do a using, because suppress change notifications it implements iDisposable. We put it in a using block. So anything in that scope, we're guaranteeing that whilst between 101 to no matter how many items that we add or remove into the list, that's a single screen redraw operation. So we ship a very implementation of an observable collection. I highly recommend you check out Roland Pheasant's dynamic data. He comes from a financial trading background, and that's one thing they excel at, is mapping streams over time and values over time. And his collection is absolute, his library is absolute Rolls Royce. Highly recommended. I'll send a link to it in public chat now.
Just trying to run through the questions here. I see somebody asked, is there an inbuilt IOC? There's no inbuilt IOC. There is a service locator that's provided via the Splat library, but there's no inversion of control. I mean that the service locator is as close as it gets. There's no dependency injection type component built in, I guess.
Well, that's kind of deliberate. One thing about ReactiveUI you'll learn is it's not overly prescriptive. It can coexist with existing MVVM frameworks. I've used it on projects where I've taken an existing imperative-based application and I've slid ReactiveUI in on a single screen just to test it out, to see if this is going to work. Can the client grok and understand RX? If they can't, well, it's just implemented on a single page. You can rewrite that very fast, very easily. But if they can grok it, you can start sliding the concept in over time, and that's the positives of being a non-prescriptive. So within the developers, I'll give you an idea of some of the viewpoints, and people continually ask us for examples, and it always comes down to it depends. We're still divided internally about the best way to do it. We've got Kent in Adelaide who uses composition roots and actually defining in a single place in the application, and uses factories, and I've actually started to go that way myself. You've got Paul Betts who created the framework, and he uses service locator in the constructor. So having a DuckDuckGo API with a default implementation of null, and then the next line underneath for the assignment to the member, it's going to go, if null, look at service locator, else take the implementation specified. So the reason he uses that pattern is it allows you to specify an alternative implementation in the unit test. And Paul has some strong views that a lot of ISC containers aren't really designed for mobile. They're designed for warm cache resolution rather than startup speed. And we know from a mobile app point of view, startup speed and launch of the application is everything. So I've been going down the route of composition routes by Kent. We've got people who are using AutoFac successfully. We've got people just using service location, using Splat. We've got service location using constructor defaults. What do you use, Michael?
I follow pretty similar to what Paul does. We use the service locator pattern for a lot of things, and just kind of let things play out on the native platform as they are. So.
All right, next question is, if you create an observable from an event, will the subscriptions run on the same thread as the thread? And what happens on the same thread that created the observable? What happens when you throttle? So this is all about when you throttle a subscription, which thread does it run on? Over to you, Michael.
Sure. So when we set up our subscriptions, there's actually two pieces here to it. We looked, if we go back to our view model here specifically, of when we receive our data in, right? So when we receive our data in, right, we say that we want to do some unit of work on the UI thread. So it's actually, let's come up here to our search results, right? We say that whenever we get this new list of data sent back into us, observe that data on the UI thread. But there's a lot of cases where you actually want to do all of your work off of the UI thread, or you want to do a portion of your work, sort of your setup work and things like that off the UI thread. So we can actually manage that in ReactiveUI, or even just using the reactive extensions in general, with two methods. Right, so you can see here our first method is going to be our subscribe on. And this basically says, which set of threads, or where should we run the code for when we are subscribing to, or when we are publishing our data. So the names here I always think are a little bit funny because it almost feels like they're kind of backwards. But subscribe on basically means whenever we have, actually I'll do it I did it on this example, but I'm going to move it up here a little bit here. We'll move it up to here, for example. Subscribe on basically means, whenever I have this select or this throttle, I want this code to execute on the task pool thread, right? So just saying, hey, whenever this executes out there, just let that continue out from a thread from the thread pool, right? We also do have that observe on then. So if we do want to switch context, or if we actually are going to subscribe to the data and do something with it, later on we could supply that observe on, right? So down here, for example, when we create our subscription, I could tell this that I'd like to observe this, though, on the main thread. So rx_app.main thread scheduler. Right, so we've got lots of different ways that we can manage threading. Where do our subscriptions occur? Where do our, the actual streams of data, which threads are they executing off on, and everything like that. Geoffrey, I don't know if you have anything else you'd like to point out on that topic. Thoughts?
Not on that topic. We have another question about unit testing ReactiveUI and how do you create observable fixtures?
Sure. So there's lots of different ways you could do this. You can create observables. I'll just come out here into our view model, right? So if I needed to create something and fake it out, I could do something as simple as observable.return. Right, and this just gives me a way to kick out a return value, and also I can give it a scheduler to run on. Right, so if I need to give it, like, say we're testing some kind of a calculation, and I need an observable that's going to return a negative value, a simple way to do that is something like this, right? Observable.return, and then I can have an observable what did I miss? Oh, geez. I did that in a poor spot. Let me move that, sorry. Right, and I can just create a simple observable that's just going to return a -1 here. Right, this is one way that you could do it. There's lots of other ways that you can create observables. You can actually create observables from things like async calls and stuff like that as well. But if you're looking to do a unit test, this is we end up using a lot of these. Just kind of simple setups here for those observables, and then like mock objects to return that data out there.
Michael, are you able to go to your web browser and go to github.com/github?
Sure. Let me do.
So you'll see down the bottom there, Visual Studio.
Yep.
So if you installed Visual Studio 2015 recently, you might have seen an option to install the GitHub for Windows extension. So that extension, this is the source code to it, and that's actually built on ReactiveUI. What happened was originally there was the ReactiveUI, sorry, there was the GitHub for desktop for Windows, and when they wanted to develop this product, they actually lifted the source code that was closed and private, and they open sourced the source code for GitHub for desktop, and when they released this actual extension for Visual Studio. So the GitHub for desktop source code remains closed, but the source code for this extension is public. And what's interesting is if you're wondering how to unit test or potentially how to model an authentication system, you can actually look at use this as a reference implementation of how to do things using RX. So this has got lots of really good examples how to do unit testing, or even how to model, say, authentication subsystems, and so much more within there. So I highly recommend reading it. It doesn't relate too much to Xamarin, but it's all about how to use ReactiveUI and .NET. If you compartmentalize that knowledge, learning RX, values over time, learning ReactiveUI, and then separately just consider Xamarin as a case of data binding, it makes things much more approachable in an approach of learning.
All right, were there any other big questions? I feel like we got most of them here. One last one I'll answer here. We'll do one quick one. We'll do two more. There was a question asked if we can store the descriptions of when we create our declarations, and you absolutely can, right? So whenever you create an observable, you can assign those to variables, and you can pass those along later on. So I do an example of that here in the search with reactive extensions. So you can see here, I create an observable, and I can assign that to a named variable if I would like. Likewise, I can actually do that with the subscription as well. You know, so if I said like bar, it's not going to compile exactly like this, but you can do something like that, and you can assign that subscription out here as well. So you can take those and assign them out to named variables. They always return an object, never return out a void or anything like that for you. And the very last thing that would probably be good to talk about, Geoffrey, is there was a question about roadmap for ReactiveUI 7. That's probably a good place to leave it here for today.
Yeah, great. So ReactiveUI 7, the roadmap for ReactiveUI 7 is we currently have nightly builds on MyGet. You're more than welcome to use them. If you send us a message, we'll extend an invite for you to join a Slack channel. The roadmap for ReactiveUI 7 includes we're adding we've improved user error. It's now called user interactions, and it exposes a model which is much easier to actually use and how to actually interact with those scenarios, which is great. Next up, we're moving to Reactive Extensions 3.0. It's a breaking change because that's implementing net standard and the namespaces are changing, but the logic in the code, there's no real difference between 2.5 and 3, and there's minimal differences between ReactiveUI 6.5 and 7. So you can start using ReactiveUI right now at 6.5, but we would recommend come and joining us in Slack and using ReactiveUI 7. It's so close to release. We've spent a lot of time bringing up the dependencies, things like Akavash, Splat, and all those little fun things.
It's a movement in the .NET space. Just a lot of things have changed over the last year, for sure.
Unbelievable amount of change. Very exciting times.
So yeah, so with that, I'd like to say thanks to everybody again who joined us here. Thanks for hanging out. I know we went about a half hour over here, so thanks to everybody who was able to take time out of their day. I did send out in the chat again my Twitter. If you want to get a hold of me, it's @MichaelStonis. If you have any questions, I'd be glad to answer any questions or anything that you might have out there. Always glad to talk about reactive stuff or just Xamarin things in general. And we got Geoffrey out there as well, so we've got @Geoffrey Huntley on Twitter. So again, thank you to Xamarin University for hosting us here today as well. And if anybody has any questions, comments, feel free to get us online. Otherwise, I hope you have a great rest of your day.
Yeah, thank you everyone for joining us. Keep an eye out for more upcoming guest lectures in the next month or so. Also, if you have any ideas for guest lectures, if you know somebody in the community that you think would be great to have on, or a topic that you'd like us to talk about, just let me know. So that's just rob.gibbons@microsoft.com, and I would love to talk to people. So thank you everyone. I will have the video up in the next couple days after it's done rendering, and we'll see you next time.